Hi, I'm Dr. Gil Welch, and I'm going to do a short statistics short take on scatter plots and regression. And this is to prepare you. Oh, I don't know what that's about. This is to prepare you for the article you're going to look at tonight. It's one of Jack's 1975 Journal of the Maine Medical Association, but you're actually not going to look at the article. You're just going to look at the figure, one figure that has lots of parts to it. And here's cholecystectomy. I'll just bring it up, and we're going to look at patient days per capita versus admissions per capita. And there you can see the resolution isn't very good. There's some statistic there. R squared equals 0.81. I want to talk a little bit about scatter plots and correlation. So, scatter plots are a way to look at the relationship between two continuous variables. So you might imagine age of child here, and here maybe it's height. And you'd expect to see something like this. As children got older, they got taller. And a scatter plot may reveal positive or negative relationships. So here's the number of children in family. Here's the number of dirty dishes. And of course, that's going to be a positive relationship. More children, more dirty dishes. That is a positive. You can see the slope would be positive if you drew a line. Here is the number of children in a family against the pet survival rate. I'm going to argue, well, maybe that's negative. Children, less likely that pets are going to survive that, whatever. Negative correlation, a line with a negative slope. Or it may reveal a no relationship. Here's the pet survival rate against the number of veterinarians in the hospital service area. No relationship there. Correlation is something about the degree to which two variables are related. Here is a strong correlation. These two variables are very closely correlated. This is a more moderate correlation. This is quite a weak correlation. I think you can see some correlation, but it's pretty weak. And this is no correlation. So here's a pop quiz. Look at this and tell me the sign and the strength of the correlation. What would you say? Well, that's a positive correlation, and it's a strong positive correlation. Well, that is a less strong. That's a moderate correlation. And this is a weakly positive correlation. This, I don't know what it is. I'm going to say it's no correlation. I don't see any correlation. How about that? Well, actually, that's no correlation as well. For all those changes in X, there's absolutely no change in Y. That looks like a negative correlation. It looks relatively strong. That looks stronger still, negative correlation. And this is a weakly negative correlation. So you get some sense of what the strength and the slope tells you. Now, there's a very important question to ask when you look at a scatter plot, and that is, what is the unit of analysis? And this is the question of, what does the dot represent? So let's go back to this number of dirty dishes versus number of children in the family. And the question I'm asking, what does that dot represent? Well, that represents one family. That's how many children there are in the family and how many dirty dishes there are. Now let's consider this. This is height versus age of the child. What does the dot represent there? Well, here the dot represents the individual. It's not a family. This is just one person that is so old, maybe 10 years old, and so tall. And go back to pet survival rate versus the number of veterinarians in the area. What does this dot represent? Well, it represents something at the area level, the hospital service area, if you will. Now we can move on to the question of the measure of correlation, the R statistic. Now, I want to be clear. For tonight, looking at the scatter plots and thinking about what they mean is more important than this statistic. And some of you already know about the statistic, but for others, I want to make sure you have some familiarity with it. So the measure of correlation ranges from -1 to 1. The sign tells you something about the slope. So if it's negative, the slope is negative. If it's positive, excuse me, the slope is positive. So a positive R means a positive relationship, a negative R means a negative relationship. And the magnitude tells you something about the strength. The closer the R is to -1 or +1, the stronger the relationship. And the closer R is to 0, either, -0.1 or +0.2, it's the weaker the relationship. So as you move towards 0, weak relationship. If you go to the extremes, -1 or +1, the stronger the. So this is an R of +0.9, a strong positive relationship. This is an R of 1. Everything falls on a line. This is an R of 0. Again, there's no relationship between these two variables. This is an R of -0.9. This is an R of -0.6. It's a negative relationship, moderately correlated. This is an R of +0.5. And who knows what the R is here? I mean, there's just no obvious correlation between these variables. And it's close to 0. And my rule of thumb is if you don't see a relationship, the R will be somewhere between -0.3 and +0.3. It's just a generalization, but if you really can't see a correlation, the R is going to be small. It'll be very close to 0. So here's a pop quiz. Guess the R. Well, you're not here to do it, so I'll guess it, and it's been a while since I've looked at these slides, but that's pretty strongly positively correlated. I'm going to guess it's over 0.9. What is it? 0.95. Okay, so I'm giving myself credit on that. How about this one? Well, there is some positive correlation here. I can see it, but it's not particularly strong. I'm going to say it's a 0.5, a 0.6, something. Oh, 0.3. Oh, I overestimated. That's just sort of the limits of what we can see. How about that? Well, that's a strongly negative relationship. I'm going to say that's a -0.8. Let's see how I do. Oh, yeah, good. I'm hot. All right, hard to see. Could be positive, could be negative. I'm going to guess it's a +0.2 or something. You can't see anything. There's nothing. That's easy. That's a strongly positive relationship. I'm going to say that's over 0.8. Oh, good. +0.8. How about that? Okay, an extra wrinkle. In tonight's article, Jack uses an R squared. So if the R is +0.9, the R squared will be 0.9 squared, which is 0.81. Now here's a problem. If the R is -0.9 and I square -0.9, that's also going to be an R squared of 0.1. So now when you square the R, you lose any information about the slope. You'll have to look at that in the picture. And in simple correlation, the R squared is interpreted as the proportion of variation in one variable that can be explained in the other, or by the other, I should really say. So in other words, an R squared of 0.81 means 81% of the variation in one variable is explained by the variation in another. And that brings me back to my most important point for tonight. Looking at the scatter plots and thinking about what they mean is more important than the statistic. Anyway, I hope this helps.